Hello Math 130 students, we're going to pick up on page 16, section 8.4, logarithmic functions. Exponential functions are inverse functions of logarithmic functions. We can write an exponential function as a log function, and we can write a log function as an exponential function. So here we have our definition of a logarithmic function, right? Any function of the form f of x is equal to log base b of x, where the logarithm of base b is defined as b being greater than 0 and b not equal to 1. So the thing that you really want to pay attention to is how to go from a log to an exponential. You can also go backwards from an exponential into a log. So that kind of tells you how to shift between the log and the exponential notation. And for number 1, of course, there's some typos, so don't pay attention to B, C, and D. The only thing we want to do, for at least now, is look at this function that I have and rewrite it as an exponential form. So if that's the case, I have that y is equal to log base 6 of 36. So this is what we're going to do. We're going to notice that whatever little number is below the g, that's going to be our base. So here, our base is going to be 6. Our exponent is going to be what it always equals to. So my exponent is going to be y. So then when I rewrite it, I have my base of 6. I have my exponent of y, and all of this is going to equal to what's on the inside. So that's going to be a 36. So I have 6 to the y is equal to 36. And that's the only thing we want to worry about, at least for number 1. Now for number 2, sorry about that. It says graph the function below by moving the key points. So we have y is equal to log base 1/4 to the x power. You can only graph integer points. For example, you cannot plot the point -1 1/4. The reason you can't plot that is because that 1/4 is a fraction. So it's just telling you, hey, when you graph this on your computer in Newton through Canvas, you want the numbers to be such that, it's like -3, -2, -1, 0, 1, 2. So either the positive and negative whole numbers in 0, but no fractions, no decimals. So you're just like, okay, well, what do I know? I know that I have y is equal to log base 1/4 of x. So this is really difficult to understand. So let's actually rewrite this as an exponential. That is going to help us. So if we were to rewrite this as an exponential, well, I would have my base as 1/4. That's the base. The exponent here is going to be the y, and it's going to equal to x. So if that's the case, then I can make some points for my x and y values, right? And it's going to be a little bit weird at first because I'm going to be plugging in my y values first. So if I plug in a 0 for my y, 1/4 to the 0 power, so 1/4 to the 0 power is equal to 1. So I get 1. So let's try something else. What if I did 1/4 to the -1 power? Well, if I did 1/4 to the 1 power, you can do this on your calculator if you want. That -1 tells you to flip it, so you get a +4. So my y value was a -1, and I get back a +4 for my x value. Notice that if I had tried to plug in, let's say, 1/4 to a +1 power, then I get a 1/4, but it specifically says you don't want a fraction. So I'm going to be plugging in negative numbers. So let's try, let's say, 1/4 to the -2 power. Well, if I were to have 1/4 to the negative 2 power, that's going to give me a positive 16. So these are going to be some of the answers that I have. Points, we are going to have 1, 0. We'll have 4, negative 1. And we'll have 16, negative 2, which is down here. So more or less, we are going to have our graph look like that curve there, okay? All right, so for number 3, it says solve. So I'm gonna have to rewrite this as an exponential so that I have my base that's equal to a. I have my exponent that's equal to 3. So this is saying a to the 3rd power is equal to 8. So let's see our possibilities. Well, 1 to the 3rd power is 1. 2 to the 3rd power, so that would be 2 times 2 times 2. So that's going to give me 8. So in this case, we have that a is going to be equal to 8. Okay. Now we want to solve for this. Well, when it defaults, when I do not have a log base anything, it defaults to be a base 10. So base 10, when base is not displayed. So it defaults to be a base 10. So when you don't see a number, it's base 10. So now when I rewrite this, I know that my base is going to be 10 and that my exponent is going to be 2. So I have 10 to my exponent of 2 is equal to that 5x minus 5. So 10 squared, 10 times 10 is 100, and that's equal to my 5x minus 5. So I'm going to add 5 to both sides. So now I have 105 is equal to a 5x. So if I divide by 5 on both sides, 105 divided by 5 gives me 21. And I just want to make sure when I plug this into my calculator, it does it correctly, or if it's an okay answer. So when I have log, and I have 5 times my 21 minus 5. Does that equal to a positive 2? And it does. So you always want to check your final answer. And what I did to check, I did the log. I have 5. And I wanted to see if it equal to 2. And that number that I plugged in was 21, because I had x is equal to 21. And so I had 5 times 21 minus 5, which is 100. And it checked out. 2 is equal to 2. That's why it was able to work out. Now for number 5, which is really different here, is that whenever you see natural log in e, they actually cancel out. So natural log is ln. So when you see the pair of ln and e, well, you know that they are going to cancel out. So here, if I have natural log, and then I have e to the 3x is equal to 15, well, like I said, natural log and e cancel out. So then I'm going to be left with a 3x equal to a 15. So if I divide both sides by 3, so I get that x is equal to a positive 5. And so that ends up becoming my final answer. So now for number 6, it's going to be the same process. So I like to kind of just identify what the base is. The base is a, and you have the exponent of 2. So here you have a squared is equal to your 36. So what number squared is going to give you 36? So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and 6 squared is 36. Well, this is what you want. So you know that your a value is equal to 6. 6 squared is equal to 36. Okay, and that's the end of section 8.4. If you guys have any questions, please feel free to contact me. Thank you.